Wednesday, February 10th. Make sure you join the pear deck. And today's first problem, I'm going to send you guys a link for the formula sheet in case you don't have it. You should have these in your notebook, but there's a reference sheet, so you will need to know the Boolean algebra simplifications. So you're going to simplify this sum of products logic expression using Boolean algebra. So I just sent in the chat the reference sheet. I'm going to give you guys 2 minutes. Go ahead and try that. I'll give you a hint. The first thing you're going to do is distribute or FOIL. I only have 8 students join the pear deck. Make sure everybody joins it. All right, I'm gonna give you guys another minute. Make sure you are in the final reduced form. Make sure you can't like factor something out. Ten seconds left. If you haven't joined the pear deck, you can still join. Okay, so it looks like only 4 of you guys got it right, but that's still pretty good. If you put C, it just means that you could have further reduced it by 1 more step. So I'll show you guys. So I'm not too mad if you put C. The correct answer was A. So first, what you're going to do is FOIL. You're going to multiply first, so not x times not x. Outer, not x times y. Inner, not x times y. Last is yy. Then, so that's theorem number 15. And then we can use theorem number 3 that tells us x times x equals x. So the first minterm, we can just simplify to not x. And the last minterm, we can just simplify to y. And then we can use theorem number 7, which tells us that x plus x equals x. So we've got not x times y plus not x times y. We'll just get not x times y. Then, so some of you guys put that for C. You could have done one more step. So if you notice, not x and not xy both have not x in them. And this one's kind of hard to do because you have to like factor out. When you factor not x out of not x, you end up with 1. And when you factor not x out of not xy, you end up with y. So you get 1 plus y. The reason that's important, we know 1 plus anything gives us 1. And then 1 times anything gives us that number. So our final form is not x plus y. All right, does anyone have any questions about that? Or want me to clarify anything before we move on? Okay. So just some brief announcements before we get started. Some of you juniors got a message from me yesterday on Teams with information about the Marathon Oil Internship meeting, which is today. It's during office hours 12 to 1. I should have sent you the event link. If you didn't get that and you think that that's something you're interested in and you have a GPA of 3.5 or higher, some of you guys didn't get invited because you have to have that 3.5 GPA. So if you think, like, if you're interested, just send me a message. I can check your GPA if you don't know it, and then I can send you the link because it is possible that I could have missed somebody. But just a reminder, that's at 12. Genesis applications are going to be due March 5th, not March 1st. Again, I encourage all juniors to apply to that because we don't have externships this year. So if you want to do something like that, you're going to have to do either Genesis or Marathon. Again, I understand some of you guys like are too involved with like band and engineering, and you want to take all these classes your senior year, so you can't really fit just 4 periods in the schedule. If you're just interested, though, you can still go. Just going to the meeting doesn't, and also with Genesis, just applying is not a commitment. If you apply and then you find out, they'll give you, so you apply, you interview, then they'll give you an offer, and you can still reject that offer. So like if they say, we're going to offer you this position, you don't have to take it. So if you're interested in it, apply, and then you can decide later if you want to do it. The application is only 3 to 5 sentences. It only takes about 10 minutes. Also, reminder, exam 3 is going to be Wednesday next week. On Monday, I'll give you guys a review sheet, tell you what's on the exam. It's not going to be cumulative, so it's just going to be from the beginning of the semester. And we're also going to have a notebook check next week. So make sure your notes are up to date. I do have my notebook posted on the hub if you want to check. Also, I'll just say, I know some of you guys came from Mr. Sycam's class, and I know he has like different requirements for notebooks. He's not like as strict as I am. So if that's the case, I'm not going to hold that against you. I'll just have, I'll really just be checking from the beginning of semester 1, which I think is tables to logic expressions. So even kids that I've had in the past, if you lost your notebook, if you just never had one, now's a good opportunity. You can start fresh. And I'll only be checking from this semester. So you don't have to like make up those like 50 pages of notes you missed. If you need a notebook, please just send me a message. I can arrange for you to pick one up at the school, or if you live close by the school, I can stop and drop one off in your home, like just outside on the curb or something. Yeah, so reach out to me if that's an issue. Don't be embarrassed if you don't have a notebook, like it's fine. I'd rather you just, do it this semester. All right, does anyone have any questions for me before I get started? Okay. So we're going to start off, we're going to take notes today. So you guys are going to title your notes, DeMorgan's Theorems. DeMorgan's Theorems. And you might be able to actually keep up with the notes during class. They're not too long, but I did post my notebook on the hub if you need that. So first of all, we're just going to define what DeMorgan's Theorems is. In your notebook, you only have to write like the first sentence, and you can paraphrase it. So DeMorgan's Theorems are just 2 additional simplification techniques used to simplify Boolean expressions. And then the second part, you don't have to write that. Again, the simpler the expression, the simpler the logic. On the bottom, you don't have to write those as well. We're going to write them in the next slide, but these are the 2 theorems. So we're just going to talk about 2 today. We went over 19 last class, so today we're just adding 2. So all you have to do is just write 2 additional simplification techniques used to simplify Boolean expressions. Right. That was weird. It just said, Teams just said hold, but okay. So DeMorgan's theorems come from this old white guy, Augustus D. Morgan. He was an English guy who was born in India, so that means he was a colonizer. And he came up with these theorems. So giving him a little credit. So this is the first theorem, and for your notes, all you have to do is just write DeMorgan's theorem number 1 and just write the equation. You don't have to write the proof out unless you want to. So DeMorgan's theorem number 1 tells us that if you have A times B and you have that product inverted, then you can rewrite it as not A plus not B. So first, I just want to say that you cannot, so not A, B, so like if you have the bar over both A and B, you can't just separate those. They're basically like married together. The only way you can separate them is if you separate them and change the sign. So basically all DeMorgan realized was that so if you look on the left-hand side, not the product AB is when you take A and B and you multiply them together first with an AND gate, and then you invert that product. You get not A times B. So he went through and he looked at the truth table for that, and we found that the truth table goes 1, 1, 1, 0. And then he noticed that if you look at the circuit, not A plus not B, that means you're going to invert A, invert B, and then add them together with an OR gate. You're going to get the same output for that truth table. So you're going to get 1, 1, 1, 0. So because the truth tables are the same, that means that we can substitute one of the expressions in for the other. So basically, you can't really do anything with not A times B because that not sign is over the entire thing. So what we have to do is we have to substitute it as not A plus not B. Does anyone have any questions on that? And again, you don't have to draw the proof or the truth table. Okay. The second theorem is basically the opposite. So if you're inverting the sum of A and B, you can actually change it to not A times not B. So the proof is on the bottom. You don't have to draw the proof. Basically, this guy figured out that if you take A plus B with an OR gate and you invert it, you get not A plus not the product, or no, sorry, not the sum A plus B. So if you look at the truth table, you end up with 1, 0, 0, 0. And then he noticed that not A times not B. So if you invert A and B first and then multiply them together, you end up with the same output, 1, 0, 0, 0. So because the truth tables are the same, it means that we can substitute them in for one another, and it always works out. So you don't have to, if you don't understand the proof, that's okay. You just have to know that not the sum of A and B is equal to not A times not B. So in summary, remember we learned 19 of those theorems on Monday, and today we're just adding those additional 2. So it's 20 and 21 are going to be DeMorgan's theorems. So let's look at an example of, before we look at an example, you don't have to write anything on this slide. I would just write break the line, change the sign. So these are the easiest ones to remember, but they're not necessarily the easiest to use. They can get a little confusing. So if you look, what we mean by break the line, so we have the first example, we have A times B being inverted. So if we break the line and make the line go over A and B separately and change the sign from multiplication to addition. So you break the line, change the sign. So you separate them, put the line over each of them individually, change the multiplication to addition. The second one is just the opposite. Break the line, change the sign from addition to multiplication. So the reason we want to break these up is because if we have like not A and not B separate, the chances are it's going to be easier to simplify further with different Boolean theorems and laws. So if anything on this slide, I would just write break the line, change the sign. You don't have to write the rest of it. Okay, so let's go over an example. And this one does look really complicated, but we're going to do it together. So we're going to simplify this Boolean expression and note the theorem used at each step. So we have F1 equals, and this is really hard for me to say, not the product of x times not y times the product or the sum of not y plus z. So notice how that bar is over the entire thing. When we use DeMorgan's, we want to look at the longest bar first, break that up, and then we might have to break up other ones as well. So we're going to look at that big inversion bar on the top and deal with that first. So if you notice, this one is like two things in parentheses being multiplied. So we're probably going to keep those things in parentheses, and we're going to break the line in between those two parentheses and then change that multiplication to addition. So you notice from the first to the second line, we took that line and we put it over both the individual things being multiplied, and then we changed the sign to addition. So that's the first, break the line, change the sign. So now you'll see that x times not y has two large inversion bars over it. And theorem number 9 just tells us that it's like the double negative, not x is just x. So not x times not y is just going to be the same as x times not y. So when you have those double bars, you can just cancel them out. So on the third line down, you can see it's rewritten as just x times not y. Anyone need me to clarify that, or did I lose anybody? Okay. Then on the right side, so you can like combine two theorems or two steps in a line now. You don't have to rewrite it every time. So in this case, we also on the right side, we have not the sum of not y plus z. And since that line goes over the not y plus z, we can break that line and change the sign. So we break the line so it becomes not y, and then the one on the right becomes not z. And then we're going to change the sign from addition to multiplication, so we end up with not y times z. Then again, we have a double negative, right? We have not y, so that's just going to be written as y. And we end up with x not plus y not z as our final answer. Now, if you look at those, this is the final form. There's nothing that you can factor out of that. So you can't factor x out of it. You can't factor y or z because we have not y and y, so that's just the final answer. So does anyone have any questions about that or want me to repeat it? All right, we're going to go over another example. So this example is just showing, you don't have to draw this circuit in your notes, but it's showing where does such an odd Boolean expression come from. Take a look at this very poorly designed logic circuit shown below. If you were to analyze the circuit to determine the output function f2, you would obtain, on the right, you can see it says f2 equals not the sum of not x plus z times the product of not x, y. So how this happens, let's start at the top. We have x, y, so we have an AND gate making it x, y. Then we invert x times y, which gives us not x, y. And notice the bars over both of them. It's not x times not y, it's not the product. Then on the bottom, we have not x plus z. And then when we use an AND gate, we just add those, or we multiply those together. So we get not x plus z from the bottom times not the product of y. And then just for fun, they inverted the whole thing. So we get a bar over the entire equation. So we're going to simplify this equation. So you're going to write down f2 equals large bar over the entire thing, parentheses not x plus z parentheses times parentheses not x times y. Okay, so sometimes it's hard with DeMorgan's theorems to know where to break the line. The line is over this entire thing. We see that these two things are being multiplied together. So that's where we're going to break it. So we break the line, and you notice the line goes over the left portion and over the right portion. So it goes over not x plus z, there's a line over that, and on the right it's going to be over not xy. And then we change the sign and we put in x, or not x, a plus. So now it becomes that. I'm not going to try to read it. That's theorem number 20. And then on the right-hand side, we have that double bar, or like the double negative over xy. So theorem number 9 tells us if we have a double inversion, we can just rewrite it as x times y. Then on the left side, we have not x plus z, that entire thing inverted. Since we have the bar, usually when you have a bar over more than one term, you're going to have to use DeMorgan's. So in this case, the function is plus. So we're going to break the line, and then we're going to change plus to multiplication. So we get not x times not z, and then plus xy. Then theorem number 9 tells us to eliminate the not x, we just get x times not z, and then plus xy, and that is our final equation. So in this, you can try to factor out the x to get x not z plus y, but not z plus y, you can't really simplify that any further. So this is going to be the final form of the equation. Does anyone want me to repeat any of the steps, or did you get confused on one of the things I said? Okay, I'm going to have you guys try your own next. So this is the one I'm going to have you do on your own. Make sure you can write it in your notebook, or you can put it in, like on a separate sheet of paper. So you're going to simplify this expression. You don't have to note the step at each, or the theorem at each step, and then put the answer in SOP form. So I want you to simplify not the sum of not x plus y times x. So go ahead and try that, and I'm going to give you guys 2 minutes starting now for your answers in paired F. I'll give you a hint. You're going to want to use DeMorgan's on the first term first. So you're going to use in the parentheses, you're going to break the line, change the sign. So you guys have about another minute left. Okay. Let's see how you guys did. So it looks like okay, only 2 of you got it right. But if you put C, there's just like, or no, not C. If you put, I think A, no, I think you just missed a few simplifications. So this one was really tricky. I'm just impressed that 2 of you got it right. It's really hard the first time you do it on your own, so let's go over it together. So the first one, we're going to break the line, change the sign. So we break the line between x and y, change it to addition, and we get not x plus not y. Then we're going to use theorem number 9, which tells us the double negative, so we can take not x and rewrite it as x. So we get x plus not y times x. And then you're going to distribute this through, so you get x times x not y. And then remember, x times x, whenever you see that, you're just rewriting it as x. So x times x gives you x. And then once you have that, we can go one step further and we can take that x out of those 2 terms. So x divided by x is going to give us 1 left over. And then x not y divided by x is going to give us not y left over. So that one's, I think students struggle a lot with that. Being able to see that both of them have x, and then knowing that when you divide by x, you still have 1 left. The reason it's so helpful, so after you see it a few times, you'll remember. It definitely takes practice, but the reason it's so helpful is we know that 1 plus not y, or 1 plus x is 1. And so 1 times x just gives us x. So I think a lot of you got up to like the 4th line. You just didn't realize to reduce that to x and then also factor the x out. Does anyone want me to repeat any of that, or did anyone get lost at what I did? All right, you guys are a quiet class. Okay, so that being said, that's going to be it for the lesson today. Today I want you guys to complete your notes, and then on the hub there's a quiz called DeMorgan's Theorems. So if we go on the hub, under plans, I have a copy of my notebook, so if you want to see how I took notes, or if your notebook isn't up to date, I should put a slide actually where it says like beginning of semester 2, so you guys know where to start and where I'll be doing the notebook check from. And then also the formula sheet is there with all the theorems. This should not be here. And then there's a quiz. Oh, and I didn't add, let me add the PowerPoint real quick. All right, so the PowerPoint's there so you can take notes. And then the quiz is a little tricky. If you're struggling with the quiz, I'll be here the whole period. I would encourage you to try it during flex. And I can work through problems with you if you need them. But if you feel confident, you know, go work on the quiz. If you have any questions, I'll be here. You can come back during flex. That being said, do I have any questions? Or does anyone have any questions for me before I dismiss you? Okay, so you guys can, if you want, you can go to flex. If you want to stay back, I'll be in the meeting the whole period. I can answer questions. I can do the quiz with you if that helps. Otherwise, Friday is a B day, so I'll see you guys next Monday. Make sure you get your quiz done by midnight. Bye, everybody.
Bye, Ms. Morris.
Bye, Anshi.
Ms. Morris, I was
Yeah?
able to turn in the quiz last night.